So getting your .NET Core apps up and running with Docker is quite straightforward, but getting your .NET Core apps running in Docker with HTTPS is a little bit more involved. So if you want to learn how to do that, it's coming up next. Well, hello, wherever you are, whenever you are. Where am I? Locked down again in Melbourne, Australia. And when is it? It's July 2020. Well, I hope wherever I find you and whenever I find you that you're happy, safe and well. So yes, we've been locked down again here in Melbourne. Nonetheless, I think it's the right thing to do. We need to try and get on top of this thing, don't we? So hopefully we can all move on with our lives. Anyway, in today's video, today we talk about packaging your ASP.NET Core apps in Docker, but with HTTPS being available. Not difficult, but there's a few steps involved and there's a few little gotchas along the way. And so, hopefully, if you come with me now, we can go on that journey together and you can get your apps up and running in Docker with HTTPS. So let's get started. So welcome to episode 5 of season 3, in which we look at how you can package an ASP.NET Core 3.1 app in Docker and ensure that you have HTTPS available as part of that. So let's just go through what we're going to cover today. So tutorial overview, which is what this is, is what you're watching now. I'll take you through what we're going to build by way of a small demo in a second, and then I'll go through the ingredients and tooling. We'll do a quick Docker overview, just clarify what images and containers are and a little bit about why we're using Docker Compose. That's fairly brief. We then move into the practical part of the tutorial and we'll scaffold up our API. We'll package it in Docker and we'll attempt to make a HTTPS call to it. You can probably tell there from the 3 dots that all will not be well and it won't work. Oh dear. But don't worry, we're going to rectify that and we're going to configure it for HTTPS. We will create a certificate. We will use user secrets in combination with our certificate password to read that into Kestrel. We need to pass over some additional environment variables to our container at runtime, and we'll run all that at the Docker CLI using the run command. Now, that's a very lengthy, horrible looking, cumbersome command line prompt, so that's why we then move into the final section and we adopt Docker Compose to end up running our container in a much simpler, easier, reusable way. And then final thoughts and supporter credits. So let's take you through just very quickly what you'll end up with today. So this is the code you will ultimately end up with. Now we start off with scaffolding the API. As I've said, we will introduce a Docker file, which is here. We package this, using this Docker file, we package this app into an image. And then, if I still have it available, we use this horrific command line prompt, along with some other config that we have to do to run that up to ensure that we have HTTPS available to us. Now, I don't know about you, but that's not something I want to type in whenever I want to run a container. So that's why we then start using Docker Compose, and we basically take this stuff and we put it into a Docker Compose file, which means that we can simply run Docker Compose up, or as you saw there, Docker Compose build if you want to build the image again, and that will run up our container. And you'll see it's listening on port 443 and port 80. And if we move over to a web browser, which I already have running, and we run that, you can see that yes, we have a HTTPS endpoint coming from our Docker container. And you will see that we are using localhost and the self-signed local host development certificate as part of that. Just quickly show you the redirect from standard HTTP as well. That works too. We leave in the HTTPS redirect stuff that I so cheekily removed from my original video. So you'll end up with app in Docker with HTTPS support with a nice self-signed local development certificate. Alright, so let's just go through the ingredients you'll need if you want to follow along today. Text editor, I recommend VS Code. You can use Visual Studio as well, or any other text editor if you like. .NET Core SDK, we're using version 3.1 today. A web browser's fine, just to test the HTTPS features of what we're doing. And of course you'll need some instance of Docker. So if you're a Windows 10 Pro user or a Mac user, that'll be Docker Desktop more than likely, and if you're a Linux user, that will be Docker, I think it's Community Edition. I'll put links below to download. Now, if you're a Windows 10 home user, and I suspect there's quite a few of you, unfortunately you can't install Docker Desktop on Windows 10 Home, but what you can do is install this thing called WSL, which is the Windows subsystem for Linux, and you can then install Docker on top of that. And there is a very detailed article on the Docker website. I will link to it below and you can follow that. Now, I've not personally installed Docker using WSL. I have installed WSL, so I have a version of Ubuntu running and it was really easy to set up. Not installed Docker though, so I'd be interested to see how easy or not that is. I suspect it's pretty straightforward. And if you want me to make a video on that, I'm happy to do that. All right, so let's just move back to what we're talking about today. Let's talk a bit about Docker actually, just to refresh us on what it is and why we're using it in the first place. So Docker is a containerization platform, and that means you can package or build your applications into something called images, and you run those images as containers on any platform that can run Docker. So lots of uses. One of the main uses is that it avoids this whole situation where you build code on your own machine and you give it to somebody else to run and it doesn't run because there are missing dependencies and all that kind of stuff. If you package something using Docker into an image, it contains everything it needs to run. And so long as you're then using Docker or running Docker, you can take that image and run it up. Use it all the time to spin up things like Postgres really quickly or SQL Server even. Great platform. Highly recommended. And it's of course used in the microservices landscape. You run microservices by and large as containers. They're self-contained, they're isolated. You can scale them out, do all sorts of cool stuff with them. So definitely something you should be familiar with. So how does it work? Well, we're going to write some app code, in this case .NET Core or C# code to write an API, and then we will introduce a Docker file into our project, and all the Docker file does is tell Docker how to package our app into an image. So you will then feed or run this Docker file through the Docker engine, performing a build effectively, and you will build a Docker image. That's what you'll end up at the end of this. You'll then take that image and then you can run that image as a container. And in order to run it, as you can see here on screen, you'll need, as I've already said, your OS, whatever that happens to be, with Docker running on it. And you will run up an image as a container. And as I said, you can run multiple containers of the same image or different images or whatever. It's all good. But in your mind, the main thing you need to make a distinction between is an image, which in my way of thinking about it is like a template or a blueprint. If you're thinking about it in terms of object-oriented programming, I'd almost think about it like a class. And then when you come to running that class, you run it as an object, or you instantiate it as an object. Similar sort of concept. So Docker's an image, a blueprint of your code, and then you run it as a container. Now, what we're going to be doing today by way of configuring stuff for HTTPS is we're going to be at the point when we run up our image as a container, we're going to be passing in some environment variables, and we're also going to be configuring some volumes. And we will do that at the point at which we run up the container. Now, that will get really, it's not complex, but it'll get really long and verbose, and it's not something you would type out at your command line every time you wanted to run up a container. We'll do it once, but that's enough. So in order to simplify that, we're going to use something called Docker Compose. And what that will do is basically simplify what we need to run at the command line in order to spin up multiple containers, or even just one container in this instance. So we're going to be using Docker Compose as well. And another benefit, as I've kind of denoted there, Docker Compose will allow for inter-container networking, which you don't get out the box. Out the box, containers are isolated by design. You want them to be isolated, so if they fail, and they don't typically, they're not able to talk to each other. You need to use some other mechanism to get them to talk to each other. There are various ways of doing that. Docker Compose on your desktop is by far the easiest and best way of doing that. So you get that networking as well by using Docker Compose. And there will be a Docker Compose file that we will use as part of that. So just quickly, some benefits of Docker Compose. It reduces reliance and simplifies the use of the Docker CLI, which you will see allows you to run up multiple containers really quickly. And as I've said, it allows you to provide networking between containers. I think with that though, let's start building. All right, so let's start with our build of our API. We're just going to scaffold up a very simple out-the-box web API that you get with the templates that come with .NET Core. So just started Visual Studio Code. I'll open up a command line. That was Control apostrophe, and I'll move into my working directory. So season 3, CD episode 5. There shouldn't be anything in there, and there's not. So let's do a quick .NET version just to check that we've got the SDK installed. If you don't get that or you get an error, just Google .NET Core SDK download and follow the instructions for your operating system. It's quite straightforward. So we then just want to do a .NET new. If you do .NET new, you can see you get a list of all the different templates we can use. We are going to use Web API, which just gives us a Web API. No surprises there. So upkey, Web API, we'll give it a name, call it Weather API, move my cursor out of the way, and hit enter, and that will go away and scaffold this up for us. Cool. So a quick directory listing, it's created a folder with all our project collateral in it. To open it in code from our command line, we type code-r and then just specify the name of the folder, and that will open that up in code for us. Cool. We'll probably get a little pop-up here. Wait for that to happen. Yes. Cool, so we now have our web API up and running. Now, before we even run anything, what I want to do is just draw your attention. I'm going to open up our certificate. So in Windows, type cert, and you can see it's brought up the Manage User Certificates plugin. And this is kind of like when a magician's on stage and he's showing you there's nothing up his sleeve. I'm kind of doing that same thing here. And what I'm showing you that I don't have, which is a bit counterintuitive, is that I don't have a local self-signed certificate for localhost for our development environment. I don't have that here. So there's nothing in personal certificates, and more importantly, there's nothing in the trusted root certification authorities. Don't be fooled, there's one called local shop, that's something separate that I'm working on, but there's nothing for localhost. Just making sure there's nothing there. Now, the previous video I did, I'll put a link up there. If you want a bit more of a deep dive discussion in that, go and check that out. But we're going to be using certificates a bit here as well, so we'll cover it off as and when we need to. So before we run this up, I just want to draw your attention to the launch settings JSON file in our project, and there's a number of profiles here. Now, depending on how you're running up, your application will depend on which one will be used. Because we're using the .NET CLI to do a .NET run, this is the profile that will be used. And more importantly, what I want to draw your attention to is this application URL here, and you can see we have two, HTTPS, localhost on port 5001, and a semicolon, and then HTTP on port 5000. Okay, so that's telling Kestrel, listen on these two addresses for HTTP and HTTPS traffic. Excellent. Now, the other thing I will draw your attention to before we move on is in our startup class, over in our configure method, and as it says here, this method gets called by the runtime and it's used to configure the request pipeline. You will see the use of this HTTPS redirection. Stick a pin in that for the moment, but as the name suggests, it redirects stuff to HTTPS. Fairly obvious what it does, but just bear in mind it's there, okay? Now, we don't have a self-signed certificate, and we're using HTTPS redirection. Bear both of those things in mind. And also, we're expecting to listen on HTTPS. So let's see how that manifests. Also bear in mind, we've not even touched Docker yet. I just want to take you through this step by step so you kind of get how things fit together. So let's open up another command line within VS Code. Again, Control apostrophe, quick directory listing. We're inside our project now. And let's do a .NET run, see what we get. And we get a horrible looking error. Now, what this error is, by and large, is basically saying we're unable to configure HTTPS. No certificate was specified, and the default developer certificate could not be found, and that's the certificate I was prattling on about earlier on. So we can create one now. Before we do that though, I just want to labour the point and show you something. So let's take out this endpoint here, the HTTPS endpoint. Let's take it out, do a Control X, and then Control S to save. So we're now only telling Kestrel, forget HTTPS, just use HTTP. And let's see what we get. So we've not created a certificate yet or anything like that. Upkey.net run, and our application runs up fine. And you can see it's just listening on localhost. So let's do a Control click to open that up, and it's opened on my other screen. Let me pull that over. And you can see here, let me just minimize that a little bit. There you go. You can see it can't be found because we do need to specify the name of our controller, which is weather forecast. If we hit enter, it brings back that on HTTP. And you can see if you click on this, it's not secured, but we do get the data back. Now, what I want to draw your attention to is here we get this warning, okay? It's saying failed to determine the HTTPS port for redirect. And that comes from when we attempted to do the HTTPS redirection. What we specified here was a HTTP point. I need to be really careful I use the right term. We requested HTTP, plain old HTTP. .NET Core then tried to redirect us to HTTPS, and that's what that warning is, okay? So let's do a couple of things. Let's go, this is still running, yep, so we'll do a Control C to kill that. And let's go back to launch settings JSON. And let's, if we do a Control Z to undo, it puts back our HTTPS endpoint. Make sure you save it. Now, if we run that up again, it's going to fail. Let's do that just to get that error message again. Because in the error message actually tells you how you can resolve it. And you can run this .NET dev certs HTTP trust command. So let me just copy it from here. I do have to put in the .NET bit as well. But let me copy that, clear that down, .NET, and then paste the rest of it in. So this is the command you need to create a localhost self-signed certificate, .NET dev-certs HTTPS-trust. Hit enter. You get a warning saying, you sure you want to self-sign and trust this certificate? Yeah, we do. And we can see it's successfully added. Now, how that manifests, if we go back down here and we go back up to our personal certificates and refresh, we get a localhost self-signed certificate, and back in trusted root certificates, if we refresh, we get localhost as well. Cool, so that's there now. We've put back our HTTPS endpoint. Let's do a .NET run. And everything should be wonderful. We've got two endpoints now, 5001 and 5000 for HTTPS and HTTP respectively. And if we go back over here and refresh it, just keep an eye on this port number here. You can see that it's gone to HTTP. We've successfully done a redirect back to 5001 HTTPS. And we click on the padlock, everything is secure. So, still not come to Docker yet, but we have set everything up. HTTPS, local development certificate on localhost, trusted, running, great. So that's all good. Done with that now. Let's package this into Docker and see what we get. All right, so the next thing we want to do is come on to creating or Dockerizing or containerizing our app using Docker and a Docker file. Now, I'm actually just following along this article here on the Docker website that basically tells you how to Dockerize an ASP.NET Core application. And they even kindly provide for us a Docker file that we're going to use. Now, this doesn't go into what we need to do for HTTPS, but it does give us a good starting point. So I'll put the links to that below. For your own reference, but we're going to cover it here as well. So let's just kill a running web server and let's close down these files. Now, the first thing it suggests you do, and it's not really mandatory, but let's follow it along, is create something called a .docker ignore file. And if you've used Git before, it's very similar to a Git ignore file. We just copy over a couple of things that they suggest we do. Again, this just excludes stuff from our image at the end of the day. So probably worth doing. It makes our image a little bit more lightweight. And then we need a Docker file. So new file, Docker file. And you can see VS Code knows it's a Docker file, it puts the little whale next to it, which is rather nice. Now, just before we move on, I've actually also installed this Docker plugin for VS Code, and it basically just allows us to see our images and our running containers, and it's really useful. I use it a lot. So just search for Docker in your list of extensions, and it's the one by Microsoft. 5 million downloads, highly recommended. Cool, so we've got an empty Docker file. And so all I'm going to do actually is I'm just going to copy over the Docker file from that article. Again, I'll put the link below. And let's take a, excuse me, a bit of a step through what it's doing. So let's save it off first. So I have done other videos on this where I deep dive it. I'll put a link up here. But by and large, all this is doing is building our image. It's a multi-stage build though, and there's really two main stages. This first stage here, which is, you can see here, it's using this .NET Core SDK image, which is an image that contains everything we need to build and develop applications. So it's copying that image down, and it's using that to basically take our project collateral and build a first stage image. And that's basically what these steps here are all doing. So you can see it's copying the CS proj file over, it's doing a .NET restore to restore dependencies, and then it's doing a .NET publish to kind of create our first image build. But we don't want to use that as our runtime image because it's too big, too weighty. So that's what this next stage is, these three lines here. It uses the plain vanilla runtime .NET Core image. Again, uses a different working directory to do the build in, and it then just copies what we did up here into a folder called out. And that is basically our image that's ready to be used. And then the last thing is this entry point, which specifies the name of the assembly or the DLL that's to be run using the .NET command. Now, this is the one thing we do need to change in here. If we go to the bin folder up here, you'll see that, not surprisingly, our assembly or our DLL is going to be called Weather API. So we just need to update that in here. Now, if you want a bit more of a deeper dive, that's all I'm going to go through today. Check out my other video and I go through this in a lot more detail. But that's all you really need to know for today. And at the end of this, we'll have a Docker image. So let's just minimize that. Now, I'm just going to clear the screen and we're going to now build our image. So Docker build, I'm going to give it a name. We'll call it Weather API. And don't forget what we call the build context, which is basically just the current directory. Now, maybe before we do that, if we actually do a directory listing, just make sure that you're in the same directory as your Docker file, okay? So Docker build, give it a tag, which is basically a name. And this name is important, so I would make the name the same as the name of our assembly, okay? And you cannot tag it with capitalization in the Docker command line, you have to keep it lowercase. And don't forget, yes, to put the build context. So if we move over to the extension, you should see some things happening now. Basically, Docker's now going to run the file through Docker and make sure Docker is running. I've got Docker desktop running down here. And you can see here, it just starts stepping through the steps in the Docker file. Now, because I have no images locally on my machine, what it's doing is it's finding this first image here and it's basically bringing it down for use to perform the rest of the build steps. And what you'll see here over time is these two images will eventually appear, the SDK image and the runtime image, and also our image that we are building will appear here. So we should end up with 3 images. You may also see some stuff happening in the container section, because basically what Docker does when it runs through the Docker file, it actually spins up a container to perform the build actions as well. So at the moment it's still just pulling this down, but you may see some activity here. Like so. So the first image is down, you can see it's running a container to do the first part of the build, and you can even see that it has little icons to denote whether it's running or stopped, and you can see it's now cleared that one down, it's gone now, it's used that container for this part of the build. And it's now pulling down the second container, which is the runtime image, and you'll see that appear here. So, yeah, we may as well just wait for it to finish, and there we do. So we've got our SDK image, our runtime image, and our Weather API image that we have created for ourselves, which is good. So we'll clear the screen, and now what we want to do is basically run up our weather API image. Now to do that, it's Docker again at the command line, run, and we specify the name of the image, in this case, weather API. Now for those of you who've maybe done some Docker before, you're maybe screaming at the screen right now, but just bear with me. I do, well, I sort of know what I'm doing. So what you'll see is it's running up, and you can see that it's listening on port 80 on all IP addresses. And you can see we have a running container up here. Now, the reason I stepped through earlier on the launch settings JSON file, and I went through, you know, listening on port 5001 and port 5000 and the environments development, I just want to draw your attention down here that you see none of that now. You did see that when we ran it natively and locally within our, you know, local environment, but when we run it as a Docker image, this is basically bypassed, okay? So I just wanted to kind of make that clear. This stuff is gone now, and you can even see that by the fact that our hosting environment is coming up as production. But nonetheless, it's now supposedly listening on port 80, so let's try and access that. Pull this over, and we go to localhost, and let's try port 80. And do not forget to put in the controller name, weather forecast. So localhost, just HTTP, port 80, weather forecast. Can't find it. So that is to be expected, and I did that deliberately because we do have to do one more thing at the Docker run command, and I wanted to do it this way just to labour the point. It said it was running on port 80, which it absolutely is, but we cannot access that port 80 from our local desktop environment. We have to map an external port into that internal port 80. So the way we do that is again back at the run command, so Docker run, and we use this P switch, and then we can give it anything we like as an external port. I'm going to use 8080, and then whatever the internal port we want to map to is. Try that again. So this looks exactly the same, but if we go back here and we try port 8080, we get our results back. Fantastic. But again, we're still just using HTTP, nothing about HTTPS, that's not being configured. Now, where is HTTPS? Where's it gone? Why isn't it working? Well, that's what we're going to basically take care of next. Now actually, just before we move on, it's probably worth taking a quick look at what's happening in Docker. So we actually have, as you've seen already, we've got our images and our weather API image, but we now have two running containers. Now, you can probably guess where they came from. They came from the first time we did our first Docker run without any port mappings, and then the second one with port mappings. All right, now you can see, certainly on Windows anyway, as far as I'm aware, when you do a Control-C, it doesn't actually kill the running containers. You have to do that manually yourself. So within this plugin, you can just simply right-click and do a stop, which we can do here. Or at the command line, you can do Docker PS, and that will, --PS maybe. Maybe it's not PS, there we go, there's no dash. So you can see the running containers here. So now we have two containers, but we only have one running container, this one here. So to stop it at the command line, Docker stop, and then just use the container ID here, paste that in, keep your eye on what's happening up here, and it will stop it. Now if you want to restart the same container, it would be Docker start. You can just paste that ID in, and what that will do is it will restart the same container. Okay, if you do let's just stop that again. If you do another Docker run, it will spin up another container. If you do it using the syntax I've used, and then Control-C, it keeps it running. Docker PS to see the running container, and you can see it's obviously got a different ID, so Docker stop. So again, just a few commands for you, and just the distinction between running and starting, they are slightly different. Now, the other thing I just wanted to take you through, it would be entirely reasonable for those of you that maybe know a little bit about HTTPS to suggest, well, okay, we've done a port mapping of a random external port to port 80. What would happen if we just extend that and map another port, say 8081 this time, to port 443. And for those of you, again, who know a bit about HTTPS, 443 is the standard HTTPS port. That's a very reasonable thing, and in fact we actually end up doing this a bit later on, but we have to do some other stuff to get HTTPS working. So again, you can see here it's run up okay, it's fine, but it's still only listening on port 80. And of course it's spun up another running container. And we could try browsing, well, let's just do it just for completeness, 881, and we'll put HTTPS in here. So HTTPS to our local port. Let's just make this a bit smaller so you can see that we're trying to hit this one here on HTTPS. It doesn't find it, which is not surprising. So now we're going to come on to rectifying that. Okay, so I'm just going to Control C that. I'm going to stop this, and I'm also just going to get rid of all those containers. We don't really need them just now. So yes, we're moving on to actually enabling HTTPS within our container. So we need to do a few things. First thing we need to do is create a new certificate. It's basically just a development certificate for localhost, but we need a separate one that we read in to our container, and there's a specific requirement around it, which we'll cover. We need to read in the password for that certificate, so we need to create a user secret for that, and then finally we'll run this up at our command, well, not finally, second last thing we'll do is run this up at our command line using a whole load of command line expressions, and then finally we'll move on to moving that into Docker Compose, which I think is a nicer solution. So I'm going to bring up another command line because it's a bit bigger for you and you can see what's going on here, and we're just going to generate a certificate here. So it's very similar to what you've already seen. We're just going to use the .NET dev certs command, HTTPS EP flag, which is export path. Now, as I'm using PowerShell, I'm going to access my user profile environment variable this way, env user pro, and doing a tab will fill that out. Now, big thank you, I can't remember what your name was, but somebody in my last video pointed out you can do that tab completion, which is excellent. Thank you so much for that. And then we just want to specify the path to where we're going to export this certificate to. Now you can, I suppose, put it anywhere, but the standard convention will be ASP.NET /HTTPS / and then you give it the name of your certificate. In this case, we're going to call it, actually we're going to call it weatherapi.pfx, and then we give it a password, obviously give it anything you like. Now, this is going to be the name of our certificate, and I have made it the same. If I get up our Docker file, I've made it exactly the same capitalization as our assembly name, okay? Because that will come back later on. So I would suggest you do the same thing if you want an easy life. So let's hit enter. Now you can see here it says a valid HTTPS certificate is already present. That's because we've already got a localhost certificate that I showed you earlier on. This is just basically the same copy of it, almost not exported, but recreated with a new file name, or a file name. We've exported it as a file. And to see where that is, let's just go into here. And so actually before we do that, I'll just show you what my user profile would be. Let's just see users at the res J. Now, if you are using Windows command prompt, I think it's something like, and it's just user profile surrounded by %signs. And I have put a link below to an article that Microsoft have actually written that actually takes us through this process. I'm sort of following it loosely, but not in its entirety. And if you check that out, if you're using Linux or Mac, you'll have the command line that you'll need to run there as well. But yeah, just to check out where that is, if we go over here to C drive, users, res J, ASP.NET, HTTPS, we just have this PFX file named as we've named it, with a password that protects it. Cool. So that's basically our our certificate created. All that we need to do now is actually trust it. Now again, we probably don't need to do this on this occasion, but let's just do it anyway. So .NET dev certs HTTPS trust. And it will just say, yeah, we've already, trusting the HTTPS development certificate was requested, a confirmation prompt will be displayed if the certificate was not previously trusted. In this case, it has been, and we get the same message. So we didn't really need to do that, just doing it for completeness, just in case you didn't have a local development certificate in your certificate store. All right, so that's all good. So now we can move on. We need to basically read in the certificate into our Docker container, but we need to be able to pass it through the password that we've used to protect it. And the way we do that is with user secrets. So what are user secrets? User secrets are something that you will use within your development environment. I will stress that it's for development environments. And basically all user secrets are a way to store or squirrel away sensitive bits of information that you use within your development environment. So things like database passwords, or in our case, password to a certificate. So when we set up user secrets, we'll do that now, they eventually, they're stored in just a plain old JSON file as key value pairs. Now, they're not encrypted or anything like that, but they are stored away under your user profile on your file system. So only you can get access to them as a developer, unless you give somebody else your login password, which again, I don't recommend you do that. So for development environment, only you can access them via your file system profile. So we'll set those up now. Before we do anything at our command line, we need to move back to our project and move into our project file, or CS_proj file. Now the only thing we need to do here is actually create a couple of tags within the property group called user secrets ID. Okay, so let me just copy that over. So we have a pair of tags, and do not forget to terminate, otherwise you'll get an error. So user secrets, pluralized, capital U, capital S, capital I. And all you need to do in between these two tags is just provide a unique ID, and that's just used when we eventually a secrets JSON file will be created. You get one for each project, so we just need a unique ID to put it in a unique folder. You'll see how that looks in a second. So I just use a little plugin extension for VS Code called insert GUID. If you want to see what that looks like over here, insert GUID. I only ever use it for user secrets, but it saves a couple of seconds of time. So just place your cursor in between the two tags, hit F1 if you have this installed, type insert GUID, click it, and it just provides you with some randomly generated GUIDs. It's cool. And I'm just going to also prefix it with season 03, episode 05. Again, you don't need to do this. This just needs to be unique. I'm just doing that so it makes it a bit more readable for me when, well, you'll see in a minute what benefit that gives you. Save that off. And that's all you need to do by way of user secrets within our application. All right, so the next thing we need to do is over at our command line, we need to create a user secret. Now, in order to do that, you need to actually be in the project directory. So I'm just going to change into my D drive. Oh my goodness. Season 3, episode 5, weather forecast. It's really cold today, and my fingers are freezing up. My excuse. All right, so we're in our project directory, and here's our weather API CS_proj file. So you need to be in that directory for this to work. And we just use the .NET user secrets command with the set flag, and then we just set the key and the value. In this case, we want to set up a password for our certificate. Now you can do this in a number of ways, and the way I would have typically done it in the past was just to give the name something like cert password. And when I was talking about, that's the only bit of programming or bit of coding we need to do over here, if I was using this method to set up a user secret for our certificate password, we would have to do more coding over in our application to actually find that key and load it in. But there is a bit of a shortcut where you don't actually need to do any further coding here, which is really nice. And the way that works is by actually giving the key value a specific path. And if you give it a specific path, then the way it's read in by the .NET Core configuration API means that it knows, in this case, Kestrel knows exactly what that value is for. So it saves you having to do any coding, which is a really nice feature. Now, there's a whole topic area on its own, how you configure Kestrel. I've put a link to a really good article by Microsoft below if you want to read a bit more about the ways you can configure Kestrel. I'm going to use this method because it's actually really, really nice and it saves a lot of time. So the key is Kestrel. Let me make sure I get this correct. Colon, certificates. I'm just making sure I'm typing this correctly. Development, and then you can probably guess the last one, password. So again, using this kind of, I guess, unique pathway key definition, that will then just automatically be loaded into Kestrel without having to do any specific config work in your code, and it all works well, all works fine. So password, make sure we get the right password. So let me just look at this. .NET, user secrets, set, Kestrel, certificates, development, password. Okay, cool. So key value, in this case, the key is a kind of longer string that specifies exactly what it is we're passing in. And we don't need to do any further coding. So we hit enter. That's just going to work anyway, unless you've set something else up wrong. It's just a very simple process, and the way or where that's stored is we go back to our C drive, into users, under your specific user profile, under app data, under roaming, under Microsoft, and then under user secrets. So again, only you can get access to this. Now you can see here I've got a few projects. The reason I tagged this particular one is so I can identify it without having to refer back to the project file, and you can see we have a secrets JSON file. Let me just open that up. And yeah, very, very simple JSON file, key value pair, as we've already stated. Cool. So that's our user secrets set up. Hopefully that made sense. Now all we need to do is actually run this up at our command line, passing in quite a few command line parameters that will take in our certificate, will take in our password, and a few other bits and pieces as well. But we're almost there. All right, now just before we move on, actually, we do need to rebuild our image because we've added this user secret. It's not yet included in our image, and it will be required by our image to understand, and you'll see this in a bit, where the user secrets file is located. So let's just come back over to our images. I'm just going to, just to be paranoid, I'm just going to remove this image. You don't have to do this, absolutely do not have to do it, but I just want to double make sure that we build a new image and it includes our user secrets as part of that. So .NET, not .NET, keep doing that, Docker build, and we just tag it weather API, and don't forget the build context. And because we've already got our base images here, it should just be really, really quick. And it should just build our builds our weather API really quickly, and it's updated a few seconds ago. So cool. So that's a really important step, and it actually caught me out because I kind of did things, making this video, I kind of jump about making it, and if you do things in the wrong order and you don't have the user secrets in the image, then when you come to doing what we're going to do now, it doesn't work. So glad I remembered that. All right, so that's all good. Now we can move on to doing the second to last part, which is running up our container, running up our image as a container with HTTPS. Now, before we do that, I just want to take you through what we're going to do. We'll do a Docker run, and we're going to specify port mapping. Now, you've seen this before, obviously. Now, we did try this before, just on the off chance that it maybe worked, and of course it didn't. Now, it's relying on the next parameters or environment variables that we're going to pass over in order for that to work. Now, the first environment variable we're going to pass over is this ASP.NET Core URLs, and we're specifying that we want to listen on HTTPS as well as HTTP. So just stepping back, if we come back over to launch settings JSON, as I said, when we ran this stuff locally, this profile was used. It's been completely bypassed when you package in Docker, but you can probably see there'll be some similarities between what we requested to happen in here compared to what we're actually doing now at our command line when we run up our container. So let's go back to that. So I just wanted to make that point. So yes, Docker run, port mapping, what URLs we want to listen on. We're going to pass over the HTTPS port that we want to listen on. Now, the only thing you need to make sure is that this port matches the external port mapping. We're also going to specify that we want it to be a development environment, not production, as you've maybe seen before, because we are working specifically within a development environment today. We then want to map to volumes. Volume in Docker is just a physical mapping through from a container to somewhere on your local hard disk, file system. So first volume is to our user secrets. Now again, you will see that nowhere in here do we specify that long GUID or unique ID. That is contained within our application, and and we had to rebuild our image in order for it to be in there. Otherwise, this step would fail and it wouldn't find our user secrets for a password, which of course is critical. And then the second volume we need is to pass in the actual certificate that we had created, which would work in this instance. And then finally, we specify the name of our image. All right, so I'm going to come back over to this large command prompt here. Let's just clear the screen. It's a bit bigger for you. Now, we don't need to specifically be in any directory. We can be anywhere because we have access to the Docker image by virtue of the fact that it's in Docker. Okay, it's just available to Docker, and if we run a Docker run command, it just knows that we have that image locally available to us. So we don't need to be in our project directory. All right, now I hope you don't mind, but I am going to copy across the command line arguments. I'll do it stage by stage, and yeah, rather than watch me typing it, which I'm sure you don't want to see me do. So I will do the Docker run component, that's fine. And then I'll copy over the other bits and pieces, which you've already just seen from the PowerPoint. So first thing is port mapping. Next one is the URLs we want to listen on. The next one is the HTTPS port. Now again, just make sure that these match. That's unfortunate, it's rolled on to the next line, but 8081 matches whatever you put here. And it doesn't really matter what you put there, by and large, as long as it's not being used by something else. Then we want to specify the environment, and that's just development. And then finally, we want to come on and specify our volumes. Now, I am using PowerShell here, so, okay. I obviously didn't copy that over, or I copied the wrong thing over. There we go. Even watching me paste it in is painful. Yeah, what I was saying is because I'm using PowerShell, I'm using this variable to get to my app data area. If we just have a look at what that is, env app data. It's just C users, lesj app data, roaming, and then Microsoft user secrets, which you've seen before. Now, the article that I've put in the description below has all the different command line arguments you would supply for OS X or Linux or even Windows command prompt. Okay, and then the last volume we want to pass over is our path to our certificate, and then finally, weather API. Okay, which is the name of our image. Hit enter. All things being well, it runs up. Now you can see a few things here. You can see it's listening on HTTPS port 443, which is looking pretty good. We've already seen it's run on port 80 before, which is fine. And we can see our environment is now development. Fantastic. And if we pop over to VS Code and we take a look at our running containers, we should see our running container here. And then all that we need to do is just pop over here, and we did have this from before when we tried to get HTTPS working magically within our container. Of course it didn't. If we hit enter now, it should work. Fantastic. So we are now using HTTPS within a Docker container, and it's using localhost certificate, okay, that we've read in. All right, so that's us done it at the command line. Now, I don't know about you, but I wouldn't want to be typing that out every time I was wanting to run up a container running HTTPS. So the final section of today's video, we're going to move all that into a Docker compose file. All right, so in this last section, we're going to now move that horrible lengthy command line into a Docker Compose file. So within our project, just click anywhere, new file, and docker-compose-YAML, and .yaml. Okay, and you can see again, Docker knows it's a compose file, and it puts a little pink whale next to it, which is nice. Now, in this instance, we've got our Docker compose file actually in our project. Fine, nothing wrong with it. Makes sense in this context because we've just got one project, but given the nature of Docker compose, it's usually working with multiple containers, multiple projects, so you'd usually lift your file, Docker compose file, to up one level of your directory structure. It makes more logical sense in my mind, so it can then reference out those other projects. Of course, you can put it anywhere and just reference the projects from within your file, but logically speaking, I think it makes more sense to do that. But for today, it's fine. We're just putting it with everything else. Now, Docker Compose, basically, it specifies what we call services. Now, the closest approximation to a service is really just a container. So it basically looks for either an image or a Docker file, and then using that image or Docker file, it will spin up a service, which is basically a running container. Easiest way to think about it. So it's a YAML file, not my favorite thing. Nonetheless, that's what we're stuck with. So you have to specify a version, and you put that in single quotes, I think, typically. So we'll just specify version 3. I've not done the research. I don't think it makes too much difference what you put in there, to be really honest. But anyway, maybe it's a bit of homework for you. And then, as I said, we just specify a number of services that we want. And you will give them a name, obviously. So this is where you have to indent, tab or white space, I think works well. And you can call it anything you like, but I'm just going to call it Weather API. It makes sense, keep it consistent. And that will end up being the name of our service. Okay, indent again. In this case, we are going to specify the build path. Now, what I mean by build path is where can we find the Docker file to build our image. You can do that, or you can just specify the name of your image if you don't want to have Docker Compose rebuild it or anything like that, if you're just using a more static image. But I do want to pass it our Docker file, and you'll see why in a second. So we're doing it that way. We specify a build path, and in this case, don't forget the colon, it's just a period, just to say the build path is here. Docker file is in the same place. All right, and then we want to specify some ports. Now again, this is really just mirroring the kind of stuff that we have up here. We're basically lifting this config out of here, and we're basically putting it into Compose, and then we can save that file off and then run that file in a much simpler, easier way. So to specify some ports, we come onto a new line, and a dash in YAML is sort of denoting an array. So the first one we want to specify is 8080. Being mapped to port 80. The next one we want to specify is 8081, being mapped to port 443, and that's us. Then want to set up some environment variables. Environment, make sure we spell it correctly. And you can do this another number of ways. You can use the array notation. I personally prefer to do it this other way, where you copy let's just copy the whole thing, actually. And paste it in here, and then we take out the equal sign and do it like that. Okay, I think that looks nicer, especially because VS Code kind of color codes it for you. Next one is our port. Now, obviously you don't have to specify the E flag. That's just for Docker command line. We've got this environment tag up here that does the same job for us in this context. Cool. And we do actually have to put that in quotes though. All right, and then the final one from our environment variable perspective is just setting our environment. Yeah, we'll copy that over as such as well, and yeah, let's put it in quotes as well. All right, and then the last thing you can probably guess is volumes. Okay. Now I'm actually going to copy that from over here, and again we're going to use the array notation. Now this looks a little bit different. The way we specify it is using this $ and then curly brackets and then the environment variable. So this will actually work in this case for both PowerShell type variables and command line variables. So it's really just using this bit here or this bit here, in case for both PowerShell and command line it's exactly the same, and the same for user profile. Okay, so again, should be familiar to you, just slightly different syntax. We'll save that off. All good. Now, what we can do then is we can use Docker Compose to run our container in a secure way, or using HTTPS in a much more simple way. So if we come back over here, let's just bring this up and we'll see what it looks like when we use Docker Compose. So you just do docker-compose up, and I think it's --build. We'll just do a rebuild of the image, and it's basically going to find our Docker file and rebuild our image. It does work. Okay, cool, fantastic. It appears to work anyway. So yes, you can see here it looks slightly different because Docker Compose can be working with multiple containers. It will sort of give it this automatic, prefix, color code it, so you'll see multiple containers running. It looks quite nice. So yeah, running on 443, running on 80, that all looks good. We've got a running container up here. You can see it has built this other image down here because we specified it as a build in our command line. So we come back over here though, should be exactly the same result, and indeed it is. If you hit Control-C in Docker Compose, it will actually stop the container, which is quite nice. That doesn't happen with at the command line, certainly in Windows, when you're just running it using the Docker command line. And if you want to just run it up rather than having to build it, you just do Docker Compose up and it will rerun the same container. You're not getting duplicates. All works nicely. Now, I actually thought, yes, one last point that's important here for Docker Compose. And that's why I was saying, I'm wondering, will it work? It will work because we've got it configured correctly. What is important, if we come back to our Docker file, we specified this is the entry point, and also when you look at the DLL itself within the bin folder, that's actually where we got this name from. It is capital W, capital A, capital P, capital I. Now, if we come back over to our the certificate that we created, users, -j, ASP.NET, HTTPS. You've got to make sure when you're running this in Docker Compose anyway, you've got to make sure that the capitalization is exactly the same. So you can see that's all working, it's all cool. If we change this to a lowercase w, same certificate, no difference. Is this running or is it not running? It's not running. And we do Docker Compose up, which you've seen had worked perfectly well before, we'll get an error, and it'll be the same error that you've seen before, which is basically saying we can't find the certificate. It's case sensitive, so just be aware of that. It doesn't appear to be case sensitive when you run it using the Docker command line, using the lengthy command line syntax. From within Compose, it seems to really pay attention to this here. So just be aware of that, and it's just for completeness, run it back up again. It's all working well. Well, that's it for yet another video. Parting is such sweet sorrow, but if nothing else, I hope you enjoyed today's video and that you can use it going forward in your own stuff. Now, if you liked the video, maybe think about giving it a like. If you've not done so already, maybe think about subscribing. But if you don't want to do any of that stuff, that's okay. So until the next time, stay safe, stay well, and to my wonderful Patreon supporters, your names are coming up now.